The TimeWise library can integrate with conventional programming languages such as Matlab, Python, and C. Here I'm going to show how to use a couple lines of Matlab code to use the TimeWise library and apply time gating to the data we collected just now. This S2P file is the data we collected just now. I copied it from the VNA to my laptop using a USB drive. Now we open Matlab and go to this directory. This directory has this data file, the TimeWise DLL file, and TimeWise header file. Let's open a new script. And name it as demo TimeWise. So first, we need to read the data from the S2P file into Matlab workspace. Here, I use the XXP parse function to read the data from S2P file. This function is nothing special but reading data from S2P file into Matlab workspace, and it can be found at a lot of places online. So figure 1 shows the data, raw data in frequency domain. The next step is to load the TimeWise library. Okay, so now the TimeWise library is loaded. Before apply time gating to this data, we want to have a look at the time domain view of the data to have an idea on how to set up gating parameters. So the next step is convert the frequency domain data to time domain data. First, we need to define several parameters. N0 is the number of frequency points. T1 is the starting time of the time domain range. T2 is the end time of the time domain range. And here we use an interleave function to interleave the real and the imaginary part of the data, which is a requirement of C++. And now we call the TimeWise library and use the F2T function to transform the frequency domain response to time domain response. And also we need to input S21, T1, T2, and 0. And the frequency span. To plot the data, we need to convert the complex data into log mag scale. Now let's plot the data. So figure 2 shows the time domain view of the collected data. The main peak is the antenna to antenna response. The other peak is the ground reflection. So now we want to apply bandpass gate to only include the antenna to antenna response. The next part of the code is gating. First, we need to define some gating parameters. So the gate type is bandpass, which is 0. And we can also define the gate shape. Let's define it as normal. And also the edge treatment. Let's choose renorm. So all of those parameters can be found in the header file here. So 0 is bandpass for gate type. Notch is 1 is notch for gate type. And we have a minimum, normal, wide, and maximum for gate shape, and renorm and sig for gate edge treatment. So now we need to find where this main peak is in time domain, and that is our gate center. Also, we need to define the gate width. As a result, the gate starting time will be gate center minus gate width over 2. And the gate ending time will be gate center plus gate width over 2. So after setting up the gate parameters, we need to call the TimeWise library to create the gate. So we use the function called createGate. And input the gate starting time and the gate ending time. Gate type, which is bandpass now. Gate shape, which is normal. And the gate edge treatment. And the number of frequency point. And the frequency span. After creating gate, we need to apply the gate. Okay, so we use the createGate function and applyGate function. So now we have the gated data, which is in frequency domain. So why this gated data is in frequency domain is because the time gating is performed in frequency domain as a convolution. We also want to have a look at the gated data in frequency domain. So we still need to use that F2T function to convert the frequency domain response into the time domain response. We call it gated TD. F2T T1, T2, and 0 frequency span. Okay, now the data process is done, and we have the gated data in both frequency domain and time domain. And now we need to delete the gate to release memory. Okay. Now let's plot data. So the gated data now is in it's complex number. So we need to plot the log max scale. Okay, so this is the gated data and raw data in time domain. So let's plot data in frequency domain. Figure 4 shows the raw data and gated data in frequency domain. For this problem, we apply a bandpass gate to only include the antenna-to-antenna response. As a result, we can get this clean and smooth curve in frequency domain. All the ripples on the antenna response caused by reflections are removed successfully. Let's briefly review this data processing. First, we read data from a S2P file. Then we load TimeWise library. Before apply gating, we need to have a look at the time domain view of the data to set up gating parameters. So we use this F2T function in the library to convert the frequency domain response to time domain response. Then we set up all the gating parameters. To apply gating, we use this create gate and apply gate functions. In the end, we use this delete gate function to release memory.